movies like Terminator movie or a Jarvis program or a Jarvis Iron Man in Jarvis and Iron Man or something. So to begin with the introduction, what it is like, a large people of us or a large portion of the population today is at the mercy of this rising technology, as we can call it. And this is all thank you to the books and movies that we have. And each generation has its own fantasy of a world being served by robots. So when we are talking about artificial intelligence, why don't we think like our lives would look something like that of the cartoon characters of Jetsons? Uh, but Jetsons are, after all, cartoon characters. You cannot expect your world to be something like that. So, like, everywhere, every week, there is some task that is being done by humans, and then there is something breakthrough that is coming into the fields and into this field of AI, and then AI, which actually seemed to be a distant dream uh, for all the researchers, is now coming into existence for all of them. So when you see AI, it is all around us, and you are carrying it in your pocket. So if you're using some voice recognition software, you are using an AI. If you're using cars and navigations, that is also an AI. Similarly, even Google uses AI for its search engines, and you know so this is what artificial intelligence is all about. So if you, for example, give you the best example would be something like Netflix or Amazon Prime. In Netflix, which is the movie suggestions of the Netflix, if you've ever used that you know that in the background there is actually AI going on. Or if you've told Alexa to order a pizza, you are probably interacting with AI more than you even realize. And that's the whole point that we are going to talk about. And the design of AI is that AI is so designed that you don't realize that there is a computer which is calling the shots in the background. So in basic terms, AI is like a broad area of computer science, and it makes machines seem like they have certain amount of human intelligence. So coming down to, it's like, so it is not only, so AI, when you talk about AI, it is not only programming a computer to drive a car by obeying the traffic rules and signals, and then it's not just that. So for example, if you program a computer or to drive a car, suppose you write down a program, and if you say it's red, if the signal is red, stop. If the signal is green, just go. But real time situations are a little different, wherein even if the signal is green, you could have some pedestrian who's crossing the road. So the computer should exhibit that amount of intelligence to actually stop if there is a pedestrian ahead and not go over him. So it is like you want the computer to actually exhibit signs of human like road rage. Coming to what artificial intelligence exactly is, there are multiple terms that have been coined, and that have been the multiple amount of definitions that have been there in literature. And when you talk just about AI, if I were to speak about what is artificial intelligence? It began in the 1940s and the 50s, and it was the ability of these new electronic machines to store large amounts of information. This we are actually going back to the 1940s and 50s, where the computer uh, was a new name. It was something very new for everybody. So when you go to, suppose you go to Wikipedia, which is the first site everybody goes to if you want to know something about anything. What Wikipedia says, and I quote, is that AI is the intelligence exhibited by machines or any software. It is also the name of the academic field of study which studies how to create computer and computer software that are capable of intelligent behavior. So this is what Wikipedia says about AI. So to put it in simple words, what AI actually is like it's a branch of computer science which is concerned with studying and creating computer systems that actually can exhibit or show some form of intelligence. So actually, it seems like a very reasonable definition, but there is there's a thin line which separates an AI from an ordinary software. So it's these are two different concepts, and they are very distinct ones. But there's a very thin line which separates these two concepts. So for this time, let us you know assume that AI is in the field of academics. You can think of AI as a sort of technology that you would use to do tasks and require some amount of intelligence that needs to be accomplished. So, with this added feature that AI systems often are, and the kind of systems that are developed or are being developed in the domain, there is a lot of uncertainty. So, to give you a simple example, it would be a chess computer versus a calculator. So, both of these, chess computer being a game computer and calculator being a normal computer. So, if you compare both of these, so both chess and arithmetic, they require some level of intelligence. But when you're playing a game of chess, there is a lot of uncertainty with regards to the opponent's next move. Your move is dependent on what and how the opponent plays. And this is what I mean by uncertainty. Uh, so, whereas in routine calculations, a calculator would give you the same result. So a calculator just has to perform very routine calculations, and there is no amount of uncertainty that's there in the calculator. So this is what the difference is. This is what I meant that the two concepts are different of AI versus an ordinary software. So to put simply, the AI is the study of computer systems that attempt to model and apply the intelligence of the human mind. So, if you are writing, for example, it is like writing a program to pick out objects in a picture. So you have a picture, the input would be a picture, and the output would be certain objects that have been identified by the program. So the task of the program here is to identify different and distinct objects that are there in the picture that has been provided as an input to our AI software. So this is what these are certain terms that are coined, or you can find these terms in various literature when you do an extensive amount of literature survey. So moving on, wherein I can just put on some other examples of what AI is. So can you say that thermostats are AI, or can you say that computers which switch to standby mode automatically are they do they exhibit artificial intelligence? So, or suppose somebody is calling you over the phone and you have the number saved of the person. The number, when that person is calling you, the name of that person flashes on your phone. So is that AI, or is it airplane autopilots. I mean, when pilots use the go when they reach a certain height, they put the airplane into an autopilot mode. Is that artificial intelligence? Um, well, we'll see the answers to these in the subsequent presentation that we have. So, moving on, the important thing that you need to know about AI is that it has always followed this classic cycle of boom and burst and boom and burst. So, there has been a long history of AI being the next big thing, and it has led to multiple researchers to publicly downplay their findings so that the hype of getting out of the hand is avoided. So ever since the start of the field, the long term AI research is what you and I will from here on call something like strong AI. So strong AI is a computerized brain which is capable of doing every intelligence task that a human can perform. So it is exactly a replica of a human. So everything that a human, say you and I, can do, a strong AI can do. This is what I mean by strong AI. And roughly, every decade since 1950s, promises have been made about the impending arrival of strong AI that is there. And every time these problems and promises were broken, the funding of all these AI is dried up. And this is what we can refer to as AI winters. I mean, there have been multiple. So, to just, for example, to just clear out this idea, I would say in the recent past, what factors have led to AI becoming the next big thing? So one is that there is huge amounts of data that is being generated every minute, and in the last 5 years, approximately 90% of the world's data has been generated. So imagine the amount of storage that we need in that we actually needed in the last 5 years to store all this information. And also now there are being advances in the processing speeds. The computer actually can make sense, and all this information that has been stored can be interpreted, and the computer is able to interpret and make sense of all the information that is being stored, and that too very quickly. So this is the reason why multiple tech giants have, or say venture capitalists have actually put a lot of funds into AI and are, they are infusing the market with cash and new applications. So when I say about AI winters, is that every time you make a promise, that every time a researcher makes a promise that, so I will come up with something in the field of AI, and every time this promise is broken, the funds go for a toss. And this is what we can actually refer to as AI winters. You know, so when we are talking about AI today, this was all 1940s and the 50s. So when we are actually talking about AI in today's day and age, in like today, if we are talking about it, it's to give you a better example. Say there is a saying in the finance department or in the finance world that there are the most expensive four-letter word would be four-letter most expensive four words are this time it is different. So this time it's different. If you say that these are the most expensive words in the finance world, and trust me, they mean a lot. So the saying is meant to imprint caution in the mind of people who are actually, looking to invest into hyped assets and all that. But so To give you an example of Kevin Kelly, who is the CEO of founding executive of Wired, which is a site you can just Google it. It the reason for this is possibly three. One is the decreasing cost of computing power. The next being, uh, you know, how the data is being available, or the availability of data to put it. And the third other is better algorithms. So all of these are the factors that are, I will illustrate each of these factors in detail right now. So when you are saying about decreasing computing power, decreasing cost of computing power, what I mean is, in order that you stimulate a certain system, there is, which is, it is not even remotely intelligent. A great number of computations are actually needed. And when you go through Moore's law, it says that the number of transistors or integrators and circuits double roughly every 2 years, and has provided computational capacity in the last 5 years. But it has been discovered during this decade that GPUs, as we call them, the chips that are being used for the graphics videos, they are eminently suited to run all these sort of massive parallel computations that are needed for AI. And building these intelligent applications it wouldn't be possible. And without the increase in cheap available computing power, we have actually been fortunate to witness all this in our times. So the decreasing cost of computation is one of the major factors why AI is people are investing into AI, and venture capitalists are very much interested into AI. And believe me, it's difficult to find venture capitalists to invest into your startups. If you have something like an AI startup or something, it's very difficult. And okay, so then coming to the second part of the second factor that I said was the availability of data. So in this availability, like, so say suppose by far the biggest inventors in AI technology, they are, who can you say these are? Say Facebook, Google, or Yahoo, or Microsoft. They are all big names in this AI field. So they have all hired almost all leading researchers in the field, and they have set up their own research labs internally. So what is common between them, or what we can say the common denominator for these companies, is that they sit on massive amounts of data, and they need to analyze this massive amount of data. And AI actually bears the promise of an automatic analysis and management of this data. And these days, this is what companies are looking for. So there is an interesting symbiosis between AI and data. It's like the brain of a child. And AI actually needs huge amounts of information in order to learn. And the companies who use this huge amount of data and information, they usually want to minimize human effort of analyzing all this data. Okay, so the data that they have is large in amount, and it actually makes no sense when you look at it at the first glance. So the analysis of this data is what these companies are looking at, and they want to minimize the human effort that goes into analysis of all this. And so this relationship is bound to fuel the development of AI, I would say. And say, the best example of this is IBM's Watson. If you ever used IBM Watson, you will know what I'm saying. So what Watson is that it is a distributed cognitive system, and it is spread out in the cloud, and it collects information every time it is being used everywhere. This means that the more the people use Watson, the better the system becomes at its job. So its data goes on increasing as more and more number of users come in. This is what IBM Watson does. Then, and this is the best example of the AI, best, I would say the best and the most recent example of what I mean by availability of data being a factor, considering for AI venture capitalists. The third factor that we have come to is better algorithms. So the first one we discussed, the first factor which we actually discussed was the decreasing cost of computing power. The second that we discussed was the availability of data, in which I give you an example of IBM Watson. And now coming to the third factor, it is better algorithms. So a new type of algorithm which lies at this heart is like the AI wave. And it is safe to say that without these, the data and computing power would amount to actually nothing. If there are no algorithms, data would make no sense, and all of this computing power would actually be useless, because all of this power has to be channelized, and that channelizing part is done by algorithms. So it might come as a surprise that it is based on technologies from the 50s, which is called artificial neural networks, which is an attempt to model the network of nerve cells in human on a computer. So it is like an interconnected web of artificial neurons that either they fire or are not based on what the input to the neuron is. So when we are talking about when we actually study these algorithms, it has now come to, we can now actually say that there is already a subfield of AI which we call deep learning, which we will touch upon in the subsequent lectures that we have. So what deep learning is that its name actually refers to the number of neural layers, or the number of neuron layers that are there. And the combination of these three factors that I just discussed is it is where the business is facing applications, and this is something that is hidden. And suppose you are a business startup, something like that, you need to look at it. It is hidden somewhere, but you need to consider all of this. So there's actually a big gap where businesses could be and where they are actually, could be versus are, is what I'm talking about in terms of building internal competency or implementing AI technology. And it's because of this gap that we maintain that there is always a hypothesis, and then there's always a disruptive force of AI, and it's very, very independent, and the future progression of the field depends on it. And this age, I think, has actually arrived. So, beginning to where AI actually started, I would say, is in 1950. Let's go back to 1950. There was this guy or mathematician called named Alan Turing, and he wrote his paper, and he wrote a paper which titled "Computing Machinery and Intelligence," and he posed a question to everybody, all other researchers. He said, "Can machines think?" And it was like the first. And then coming to 1956, the term AI, or artificial intelligence, was actually first coined by this professor in Dartmouth University, whose name is John McCarthy. So what he did is that he called together a group of scientists or mathematicians to see if machines could learn like a young child does. Okay. And using trial and error, he tried to develop reasoning. So in this project proposal that he has said, they actually, the proposal says that they will figure out, we're talking about 1956. Okay, in 1956, Professor John McCarthy, he said that they will figure out how to make machines which use languages and abstractions and concepts and all other, you know, problems which are reserved to the humans for now, that we will try to bring it into machines. This is what in 1956 Mr. John McCarthy said. And we are talking about 60 years, something more than 60 years ago. So since then, what we can say is that AI has remained in university classrooms and it has remained in super secret labs. And we need to change that, and that's actually changing right now. So, very soon, I would want to say that we want to make AI a little less artificial. We want to make artificial intelligence a little less artificial and a little more intelligent. That would be our aim as AI researchers to when we are developing AI software, for example. So, when in this question of can machines think, which Alan Turing asked, he said asked the question in 1950 or 40, and but then he felt that such machines would eventually be constructed. Of course, he felt that, but along with that, what he also realized was that how do we test if our machine that we have created has succeeded, or is it right, or is it wrong? How do we test it? So for that, he he proposed a theory of the imitation game, wherein if you can see what I'm showing in the picture is that there is an entity, a machine, and there is a human judge. So a machine, a human, and a human judge. These are the three entities that are there in our um, imitation game. And this is how you have to start. When this human judge, he engages in all natural conversation with one human and one machine. He engages with A and B, and each of these should emulate human responses. And the condition is that A, B, and C, which are the three different entities, they are all separated, and there's no means of communication between all of these three entities, I mean. So test is actually, the statement of the test is to empirically determine whether a computer has achieved intelligence or not. So we are actually solving Alan Turing's problem. We are actually trying to answer his question. So what you can see is that there is a respondent, and there's a respondent A, there's a respondent B. One is a human, the other is a computer. So in the Turing test, this interrogator, this fellow here, he must determine which respondent is the computer and which is the human. So if he should actually determine, okay, this is a human, this is a computer, or this is a computer, this is a human, this is a computer. So he must be able to tell who is the computer and who is the human in layman's language. Okay, so the test that we looked at, and when is the test set to be passed? I mean, when is it that we can say that our developed AI system has actually passed the Turing test? So it is when the interrogator cannot determine which respondent is the computer and which is the human. So what I mean, it's simple that if the interrogator, the person C, is not able to determine or distinguish between who is the human and who is the computer, then you know that our computer is behaving like a human and the machine is actually said to have passed the test. So when you are actually the okay, so now you know what is the output, and if there is no differentiation between the computer and the human, the test is said to have passed. Okay, and of course this does not mean that the machine was thinking. What it simply means is that it generated behavior which it which is consistent with thinking. So it is not necessarily that the machine has any thinking power given to it. It's just that he has that ability to think. The machine has that ability to think, is what you mean when the Turing test, the machine passes the Turing test. So there are two terms, coming to these two terms of equivalence, of one being weak equivalence and the other being strong equivalence. So the two systems that we saw, the human and the computer, are said to be we are said to have weak equivalence. And when is that? When the results or the output that they give are are the same, but they do not necessarily arrive at those results in the same way. So I, as a human, can compute 2 into 3 is equal to 6, and you, as another person, can say 3 into 2 is also equal to 6. So in the end, the answer is 6. But me using 2 into 3, or 2 multiplied by 3, and the other person using 3 multiplied by 2, these are two different approaches to arrive at the answer 6. Okay. So when there are two different approaches, you would say that there is a weak equivalence between these two systems. And however, if I use 2 into 3 is equal to 6, and another person also uses 2 into 3 equal to 6 and not 3 into 2 equal to 6, our way of thinking is also the same. So this is what the term strong equivalence means. It means that the two systems use the same internal processes to produce the results. So the only difference between weak equivalence and strong equivalence between the two systems is that there is weak equivalence when two systems arrive at the same output, but it is not necessary that they arrive at those outputs in the same way. Whereas in strong equivalence, the two systems actually give the same output, and the way they arrive at the output is also the same. So the results are same, and the way of or the approach of computing these results are also the same. So coming to the word intelligence and who is intelligent, you can see four different pictures here. The first one is a mosquito, the second one is a whale, the third a frog, and fourth a monkey. Okay, or a chimpanzee who who is said to be most closest to the human race. So if is a mosquito intelligent? Suppose it's sitting on my hand and I happen to snap it. I cannot always necessarily snap it because it has the intelligence to actually fly away, and it knows that there is some danger coming to it. So that intelligence, the mosquito possesses that amount of intelligence. Similarly, a whale, he knows that there is some prey. If a human or he has his own prey, he can sense that. He's intelligent enough to sense that. Okay. And a frog, similarly, whale and frog would be the same description, as in a frog knows when to jump if there is danger, or something like a chimpanzee who is trying to emulate humans because humans are the only persons who use pistols these days. So a chimpanzee is supposed to be intelligent. So who is intelligent? And all of these people are intelligent in their own way. And what I mean by intelligence is that there are to come to intelligence, there are actually certain factors which in regard to humans. Okay. The first one is what defines intelligence. The second is, why is it that we always assume that humans are intelligent? Or are the question three, are monkeys intelligent, or are dogs intelligent? Are ants intelligent? Or are pine trees intelligent? they are all intelligent in their own particular ways. So they exhibit that amount of intelligence, so why we use intelligence, we are trying to compare humans and these creatures like monkeys, dogs, ants. We humans possess intelligence, and we are asking, the question here is whether these animals or these creatures, whether they are intelligent. Okay, so this intelligent, in what you mean by intelligence is there is a certain amount of subjectiveness that comes with intelligence. So two different points here about intelligence. The first is intelligence is subjective, and the second is that it is a relative measure. So intelligence, when I say subjective, why we try to compare humans versus all these creatures is that, and when I said that they are all intelligent in their own ways, okay, so it is like in their domain they are intelligent. So you as a human, to be called intelligent, you do not need to be an encyclopedia, and you do not need to know everything about everything. So it's something like that, I would say. So you know if you are an all-rounder, you play sports, you are good in academics, you are good at swimming, you are good at singing, you are good at dancing, that does not necessarily imply that you are intelligent. Okay, you are an all-rounder there, you're not necessarily intelligent. So if you are good in one domain, you are said to be intelligent. Okay, and when I say intelligence is a relative measure, it is like a small child who talks easily. Okay, you don't have to teach the child to build up, say, construct sentences every time. Of course, sometimes you need to, but a small child is it just picks up what uh, how people in its environment are talking, so it tries to construct sentences on its own. So it has an intelligence to adapt to the surroundings that it is in already, the child. Okay, another example would be a dog and the owner, the relationship between them. So, for example, if the owner has left the dog at home for some days and is traveling alone, and when the owner returns back and the owner calls out the dog's name, the dog is immediately understands that it is its owner. His owner is here. Okay, so when this ability of the dog to actually identify his owner's voice is the intelligence of the dog. So it is so these two things are very important. One being intelligence is a subjective matter, and the other is that intelligence is relative. So it is something that we have that we need to adapt to the environment. Okay. Coming down to what literature or what some great minds say about intelligence is, in literature survey, I would say this is what is coined down. So intelligence is the ability to carry out abstract thinking. The next is that intelligence is actually an adaptation to the environment, as I just said earlier. So the child starts adapting to the environment, and it starts building up, and building up sentences, and it by seeing some all people in its environment. This is what I meant, that intelligence is adaptation to the environment. And you need, the child can actually think, if you see. So this is what means that intelligence is the ability to carry out abstract thinking. And now that you have seen what is artificial intelligence and what the term intelligence actually means, there are certain things that you require to know AI, and so I would call these like what AI requires, or the prerequisites to go through AI. They are very simple terms, but you need to know about them. That's the only thing. So what AI requires is that it is an understanding of all related terms such as intelligence, knowledge, reasoning, thought, learning, and all these computer related terms. You just need to know how what they mean. In simple words, that's more than enough. You don't need to go and deep dive into any formal definition of each of these, but you should know what they actually mean. That's about it. So what intelligence we mean is that what intelligence means is that it is the ability to acquire, understand, and apply knowledge, or the ability to exercise thought and reason. It's simply put all these terms that are there in literature, and they are I have penned them down here. So when you know that there is intelligence, it comes from knowledge. Okay, so the food for this intelligence is knowledge. Is Intelligence is based upon knowledge, so you need to have that. To build an AI system, that system needs to have the knowledge, about what everything is and what the context that we are talking about is. So this is what I mean by food for intelligence is knowledge. Now that we have seen what AI is actually, we would move on and what the prerequisites of AI are. We will go to the goals of artificial intelligence one by one. First one is that you need to create machines that can do more jobs than the previous ones with performance. Okay, this is a simple example. In the early human era, what you had was you had a spanner, a manual one. Okay, uh, it transformed into a mechanical clock, a clock which had keys. You need to constantly set the keys. And then, as in how generations developed, the computer came into existence. So, of course, this computer can do more jobs than its previous ones. I mean, the computer gives you time as well. So, it does computations also. So, it does more jobs than its previous ones, and it also has better performance. If you see manual calculations if you do calculations on paper, it would take you long calculations. I mean, it would take you a while to do those, but if you do that on a computer, it is fast enough to give you answers. So this is what I mean by better performance here. uh, and as in how generations go on developing, you need better performance. And this is what when I spoke about Moore's law, this is what I meant. Like, you need to have better performance, and increasingly better performance should be exhibited by all of these systems. So this is what the goal of artificial intelligence is. The other goal is to add features to machines which make which machines already don't have but human has. So the goal here is to make the machine much like a human. Okay, so which suppose you have a machine, to the computer you need to give a more human like behavior. The computer should perform more human like. And this is what the goal of artificial intelligence actually is. You know, humans can conclude from known facts. Can the computer do that? Well, not yet. Okay. So the goal should be to make the computer conclude from known facts. Okay. This guessing game of the humans, suppose I guess about something or you guess about something. Can any computer guess about something? Partially it is true, yes, but you should make the computer give more better performance in terms of guessing. Okay. And you should make the computer think when you are developing some AI software, or when you are developing an AI system, you know. And humans can make relations between new identified objects and known objects. So when you know that you've seen something and it stays for a while in your brains, okay, and when you see something similar, you can resonate with it that okay, I have seen something like this earlier as well. But can a computer do that? Not yet. I mean, it can do that, yes, but not to the level that it has uh, absolutely 100% right. It is absolutely 100% right in recognizing what is stored in memory. So this is what I mean, what the goals of artificial intelligence are. Two goals. First is to provide better performance than the previous ones, and the second is to add features to machines which machines already don't have, but the human have. But human has. Okay. So these are the two goals that artificial intelligence requires. Now coming to the fact that why humans are intelligent is like it it's because of these three factors. First is learning, second is reasoning, and third is problem solving. All of this, the ability a human has, okay? The human chose learning, okay? The best example is academics, and you keep on learning new things in academics, or even in your life, you keep on learning different kinds of things or terms or something like that, and you know why certain things are happening, okay, and you can make out why this is happening, you know the reason why that is happening. So the ability of reasoning is found in humans, okay, which is not still developed in AI systems. And third is problem solving. So first, whatever calculation it is, to write a program itself, you need some humans need some intelligence, and he should know what how to solve the problem, okay. So and then you write the program and then you test it. So actually human is intelligent in this field of problem solving. He knows how to solve the problem, and then for bigger problems he writes down programs, for example, okay. So we are talking in context of humans here, and feeling the environment. A computer cannot feel the environment of what a human can do is audio and vision, audio video, as it is said in layman's language. So audio is, a human can recognize voices, and vision is that it can recognize an object by just seeing. Humans are that intelligent, okay. By just looking at an object, okay, this is a pen, this is a pencil, and you can differentiate between different objects. And just by recognizing different voices, you recognize the voice of your people around you. You recognize your boss's voice, you recognize your colleague's voice, you recognize your friend's voice. So this ability that the humans have is what makes humans intelligent. Okay, so these three factors of learning, reasoning, problem solving, and the last one of and thinking, this intersection is like this intersection will make you say that the system is thinking like the humans, because this involves human level logic. And in the fourth box, this intersection says that there's logical thinking about systems. So systems can think logically, systems can act logically, and systems can think logically. Okay, so this is the difference, and this is like something like a confusion matrix. So if you go through this, this is formally how AI is defined in terms of a matrix. So two rows in a 2 by 2 matrix, I would say. So two rows, two columns, and their intersection meaning certain things. So now coming to the categories of AI problems that are there, there we have seen the formal definition of AI now, and now we can categorize all of these problems into three different so three different categories are ordinary tasks, formal tasks, and expert tasks. So it's more important that you just see these 3 points, and I can share the presentation with you later on. So that's not a problem for now. Since we are toward the end of this lecture, we can simply move on, I would say. So we were in these ordinary tasks, and what factors contribute to ordinary tasks is first is common sense reasoning, And common sense reasoning is developing computer systems which has more common sense. Like for example, if we let fall anything on the floor, we know that it will break, so you have that intelligence to know that it will break. So that amount of common, that reasoning that you can give is what is meant by common sense reasoning. The second factor here is perception, which includes, and which we actually discussed previous in the previous slide, was vision. One being vision and the other being speech. So audio, video is what I'm talking about here. So vision and speech is together they are called perception. So this is the second factor, perception. And the third factor is understanding of natural languages. So when you know you are communicating various ideas, and the most important thing that differentiates humans from animals is this understanding of natural languages. So you're communicating different amounts of ideas, and you know that the other person is understanding. So you are intelligent enough to communicate to the other person, and the other person is intelligent enough to understand what you're saying. So this understanding of natural language is something that is very unique, which differentiates us humans from animals. Okay. The second category of tasks is formal tasks, wherein the game playing or the chess game playing that I explained earlier was like, it's like making computers play games, and it seems to be very interesting. And that's the reason why many researchers have extensively contributed for computer game playing methods. And that's the reason you get all these new sorts of games every time coming up with beautiful graphics, and all these. So because the reason is that these are all formal tasks, and the task of the computer is to play games. That's it. So they're dedicated computers. So, and this is what I mean by formal tasks. That also there's a certain amount of mathematics, for example, that is involved, wherein you find a proof for a theorem, and finding a proof is not easy. That only mathematicians can actually have actually proved why a certain theorem stands true, and why they have arrived at this, and they have proof or reasoning for everything that is said. So the study of theorem and proving play is a significant part in development of AI methods. So if you're an AI researcher, you need to understand some basic mathematics, or and you need to understand the proof of why a certain theorem is true, or why it is so, why a certain theorem is the way it is said. So as an AI researcher, you will play a significant part in developing all these AI methods for the computer or the AI system. Okay. So when okay, so this is a question that I have for all of you. It's an open-ended question, like how do machines think, or can machines think, is what the this is a question which Alan Turing has posed. And now actually delimiting each of these three words, like can is when, is it now, or is it somewhere in the future, or is it like we need more advanced technology to arrive at it, or the second delimit is that the machine, so is human the only machine, or is there some other machines that are available, or and the third delimiter is this think word, which means that does the system know of what it is doing? So is it intelligent enough to understand, to know what it actually is doing, or what it actually is supposed to do, is the question. We have simply like broken down what Turing has, what the question that Turing had asked a few decades ago, which was in the 1940s and the 50s that we are talking about. So for us, what we know is that all of this is important, yes. And what we know is that these machines can help us in the industry, and that's good enough for us right now, is that they will automate a lot of things, manual works, and therefore the errors that are already, the manual errors that creep in when you are doing things manually, actually, those will be brought down to a certain limit. So, this automation thing is very important right now. So these are a little career insights that I can give you as to where the applications of these AI areas are. They are in philosophy, they are in fiction. So in business, which use AI systems to operate investments and investment stock options, if you see. So you always get suggestions about where to invest and what to invest. So there's an R&D team in the background for the who's working for the banks, and they are building up these AI systems to provide important suggestions. Okay, so the Netflix as a business has grown because it gives you suggestions it gives you recommendations and suggestions based on your viewing history, if you've seen Netflix or Amazon Prime, for example. So this is all AI, which is actually working in the background. So of course, AI in philosophy, wherein we spoke about weak AI, strong AI. You know, we so this point is going to be an open question still, and it still is uh, an open question. In fiction, you all know science fiction, the Jarvis program, which is very popular, or the Iron Man movie, or the Terminator movie, which is almost always strong AI that we spoke of. It is commonly like an upcoming power trying to overthrow human authority. And so now we will be in a world where there will be less humans and more of robots. So this application, these are certain applications, some of the applications of artificial intelligence. These business landscapes, I will just touch upon some certain points of these, wherein you have core technologies, you have these rethinking enterprises, you have industries, then you have humans or HCI as human computer interface.